Hello friends, today's question. A student performed an experiment to measure the speed of sound in an air using a resonance air column method. Two resonances in the air column were obtained by lowering the water level. The resonance with the shorter air column is the first resonance, and that with the longer air column is the second resonance. Then so we have these four options, and this is a multi-correct option. So we are going to check one by one each of the option. I try to find the correct ones. So first of all, let us try to understand what is a air column approach. So basically, air column is not this. Yeah, this air column is our closed pipe. It means one end is open and other end is closed. So you can say our air column is a closed pipe. So this closed pipe is having one end is open and one end is closed. And its fundamental frequency can be, you can say, generalized with respect to the length. So we can say the length of the air column, the length of air column at the nth resonance, we can write that formula as Ln is equal to 2n minus 1 and multiply by lambda by 4, where value of n is 1, 2, 3 and so on. So we have two resonances given in the question. So for first resonance, we have value of n is equal to 1. So this gives us that our L1 will be equal to lambda by 4. And for second resonance, value of n is equal to 2, and which can be write that L2 will be equal to 3 lambda by 4. So let us check each of the options one by one. And the first option states that the intensity of the sound heard in the first resonance was more than that of the second resonance. So let us start with option A. So for the first resonance, it takes place at a, you can say, shorter air column. It has a shorter air column. Therefore, it results in the stronger fundamental standing wave. Results in the formation of stronger fundamental standing wave. And At higher resonance, we can say at higher harmonics, for example, for second resonance, the damping effect increases, which leads to the weaker intensity of the second resonance. And you can say as higher harmonics appears, damping effect increases. And this leads to weaker intensity of sound. So therefore option A is correct. Option A is correct. God says that the first resonance is having a more intensity as compared to the second resonance. So this option is correct. Now let us check the second option, that is B, and which states that the prongs of the tuning fork are kept in horizontal plane of the resonance tube. Option B. So the prongs actually are in a vertical plane. You can say the prongs should be in vertical plane. In the vertical plane, so that they can effectively push the air inside the air column. This is the main reason, so that their vibrations effectively pushes air into the tube. Pushes the air into the tube. So the option B is incorrect. Option B is incorrect. So let us check option C. The amplitude of vibration at the end of the prong is typically around 1 centimeter, but the only thing is that is the amplitude is very small, that is it is around about 0.1 mm or 1 mm, not 1 centimeter. So this is quite straightforward. So our option C, you can say the amplitude of tuning fork prongs of tuning fork prongs is around 0.1 mm or it is around 1 mm, but not 1 centimeter. So therefore option C is incorrect. C is also incorrect. And we are left with option D now. So option C was incorrect. And option D gives that the length of air column at the first resonance was shorter while that than the 1/4 of the wavelength of the sound in air. So this is more or less related with the end correction. So we can say we just calculated here also, and for L1 it is lambda by 4, but if we include end correction in it, so that will be equal to plus E. Okay. So our length, we can write this as that L1 plus E will be equal to lambda by 4. Okay. This is because of the end correction. Because of the end correction. Therefore, D is also our correct option. So we can write that our L1 is equal to lambda by 4, and the inclusion of end correction will be giving us L1 plus E is equal to lambda by 4. Therefore, the actual L1 or physical air column is slightly shorter than L by 4. Therefore, the actual L1, which we can say our physical air column, is shorter than lambda by 4. So option D is correct. D is correct. So we have only two options. A and D are the correct options. So finally, we can write that options A and D, options A and D are correct. So this completes the question. Thank you.